Hey, statistics, part 2 of our regression video lessons. So after this video, there's one more video, and today is, I don't know, May. What's today? May the 13th or something. I'm not. Yeah, today's May 13th. I don't know what day you'll be watching this. It'll be sometime soon, but May the 22nd, which is next Friday, a week from this Friday. That's going to be our last day. I told you that when the seniors are done, because we have a few seniors mixed in, typically when seniors are done is when I'm done. So with statistics, there will not be a final exam, so you don't need to worry about that. I'm not sure how things are going to transpire with Corning Community College, so just not sure about all that. So anyway, after May 22nd, all of you underclassmen, you'll have one less class to worry about. Stats will be finished because the seniors, we don't have many this year, but there's a few. If we were back in school, this would probably be the time we'd be watching Moneyball, that movie. I was going to have you watch it at home, but I don't want anybody to have to purchase a movie just for class. I just didn't think that was the right thing to do, even though most of you, a lot of you probably have a Netflix or a Hulu account, and it's probably on there anyway. So unfortunately, we'll have to skip that. But if you want to watch a good movie that has a lot of statistics in it, feel free to watch Moneyball. Brad Pitt, Jonah Hill, it's a good movie. Also, that guy from the Jurassic Park that everybody likes on Parks and Recreation. What's that guy's name?
Chris Pratt.
Chris Pratt. Chris Pratt's in Moneyball. So, a couple big names there, a few big names. So anyway, here we go. How do we test for linear correlation? The R is not always good enough. The correlation coefficient is just not always good enough. When is it not good enough? Well, listen, if you put in data and you find your R value and the R is like 0.99, guess what? We have an extremely strong linear correlation. But what if it's like 0.58? It's not really strong. It's on the positive side, but you know what? It's, 0.58. Sure, it's stronger than like 0.2, but do we really have? Do they really match up? It's tough. There's that gray area. So again, mathematicians came up with this correlation coefficient idea. We quantified it using a number. Hey, my R is better than your R because it's stronger, it's weaker, whatever the case is. It's more positive. No, mine's more negative than yours. That's okay. But now we have to go a step further, because what if we're in that gray area? We can't really tell. So the R is not always good enough. We have to perform what we call a linear regression, REG for short, t-test. I'm not sure. I think on the Nspire it does say linear reg t-test, or it might just say linreg t. I know on the old 83s it just said linreg t-test. So what is a linear regression t-test? Well, there's T. What's T? T was the hypothesis test that we used when we had an unknown sigma. I don't want to get super heavy into this t-test. My purpose here is just let's use the technology we have and figure out whether we have a good linear correlation or not, whether we have significant linear correlation or not significant. So here is what you're going to do. You're going to perform this linear reg t-test. You're going to look for your p-value. What's the p-value? The probability you're as extreme as that test statistic. What was our decision-making process? Well, our decision-making process is not going to change. We're going to use the p-value. And again, if the p is low, we are going to reject the null. And if the p is high, we're going to let it fly. Okay? Folks, step aside so you can read all that. None of that is new. You've heard that already from me in a video. If we were in school, you would have heard that a million times. If the P is low, reject a null. If the P is high, let it fly. But what does it mean? What does it mean? Well, it means if we reject, it means there's significant linear correlation. If we fail to reject, well, what's the opposite? There's not significant linear correlation. Now, it's worthy to note, this is only for linear correlation. Why? Because it's a linear regression line t-test. Okay? I'm not going to make you write a ho and a ha. I think it's already built in your calculator. So this is the decision-making process. I am going to type up in a document and give you the instructions on how to deal with this on your calculator. And I think I have one here. I have a problem pulled up on my calculator. So again, we're going to use that. Okay. So if we are rejecting the null, there's going to be significant linear correlation. So let's just take a look at this problem. And again, all of these keystrokes and commands for your Nspire are going to be on the document that I'm going to type out. I think that's a little bit more efficient than you trying to, rewatch the video 5 times to catch what I'm saying. So why do we do this? Because the R isn't always good enough. So I typed in some data. I found I created a scatter plot and I made a linear regression line. And my linear regression line, my y equals mx plus b, let's see, where is it? Well, let's look here. I got my linear regression line. Here's my R value. So in this particular problem, here's my R value. R is 0.68. That goes out further, 0.681994. That keeps going, but that's how much the Nspire tells me in that little printout. 0.68. So that's 0.7. That's kind of close to that no man's land, that gray area. So what do? We got to use a linear reg t-test. When I calculate my lin reg t-test, I get a p-value of 0.204691. Now you don't need all that. All you need is this first number, right? Okay? Because what are we going to compare this to? We're going to compare this to 0.05. Why 0.05? 0.05 is our alpha level. 0.05 is the alpha level. The alpha level is the significance level of the test. Where does the significance level come from? That's right, it comes from the confidence level. So the confidence level for this test is 95%. Why is 95%? Here's a good question. By the way, if we had a final exam, this would have been one of the questions. Why is 95% the most common alpha level in a hypothesis test? And I would have asked for paragraphs because there's so much stuff about 95%, but let's go back. 95% is the most common hypothesis test level because its alpha level is 0.05. It's the best confidence level. Why? because it's 2 standard deviations, 2 z-scores from the mean. Why is 2 z-scores from the mean the statistically the most significant number out there? Well, what kind of a data point do you have that goes beyond 2 z-scores? And remember, a z-score is nothing but how many standard deviations you are away from the mean. So if you go beyond that, what's that called? If you're like 2.5 z-scores away from the mean, what are you called? You're called an outlier. So that goes all the way back to October. Remember this? Mean, 68, 95, 99.7. That's mean. 1 z-score, 2 z-scores, 3 z-scores. So it goes all the way back to that. This entry-level statistics is all about that. Everything we do is about that. And for those of you who maybe you don't even know what you're going to major in yet, but years from now, many years from now, you might have to come across some of this stuff in your job, and who knows what you're going to be doing. But if you take other statistics courses, everything, that's the beginning right there, because you have to understand the normal curve. So in this particular case, 0.2 is bigger, okay? The p-val is bigger than alpha. So what happens if the p is high? If the p is high, what do? We let it fly. So if we're letting it fly, that means fail to reject the null. So if we're failing to reject the null here, what are we doing? Well, in this case, that means not, we can say, there is not a significant linear correlation. Okay, there's our conclusion. Our conclusion is that there is not a significant linear correlation. Now, even if you look at this graph kind of has stuff, it's pretty far apart, but it's kind of, and some of you will misinterpret that and say, well, Mr. Scanlon, it's really steep. Really steep just means it's more positive. But being more positive doesn't mean that we have a greater correlation, because the strength of the correlation comes in how tightly packed they are. So even though that might be a fairly steep line, it's still, it's not tightly packed. And we're going to talk a little bit more in the last video about how we get those numbers tightly packed. There's also a number in there, and we're going to learn that word, but it'll give us a little bit more insight, and that'll be the end of our course. So what do you need to know? Linreg t-test tells us if there is a significant linear correlation or not. How do we know? We're going to run this test. We're going to compare the p-value to alpha. If the p-value is bigger, we fail to reject. There is not a significant linear correlation. If we reject the null because the p is low, then there is a significant linear correlation. And that's it. Your calculator will do all this for you. There's no formulas. There's no equations. The only thing you need to understand is some keystrokes on how to get all this stuff on your calculator and have a little bit of this basic knowledge. Okay? So really short video, and number 3 is coming our way next.